One way of proving lines to be parallel is by using line relationships. There are three that are commonly used. The first one says if two lines are parallel to the same line, then they are parallel to each other. Examples 1 and 2 down here show that. Here we have line A that's parallel to B. We also have line C parallel to B. Since both line A and line C are parallel to the same line, then they're parallel to each other. So the conclusion is that A is parallel to B. In the same way, number 2 says if line M is parallel to line N, and then N is parallel to P, that means both line P and line M are parallel to N, then they must be parallel to each other. So M is parallel to P. The second one that we have says if two lines are perpendicular to the same line, then they are parallel to each other, as long as we're in a plane. Well, in number 3, we see it says if line D is perpendicular to line E, and line F is also perpendicular to line E, they're both, line D and F, perpendicular to the same line E, then D must be parallel to F. And number 4 is the same type of question. It says if line E is perpendicular to line G and line E is perpendicular to line H, then G and H are both perpendicular with E, so G must be parallel to H. The third one also requires you to be in a plane. It requires that all these lines are in the same plane. It actually has a name. It's referred to as the perpendicular transversal theorem. And it says if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Well, here we have two parallel lines. J is parallel to K. And W is perpendicular to one of those. It's perpendicular to K. That would mean that it is also perpendicular to the other. W would be perpendicular to line J.